Kia ora and welcome to this second part of the video on electricity at the atomic level. In the last video we went over electricity is the flow of electrons, and if you do look up any definition of electricity you will often find an extra bit under this, and that has something to do with this. The build-up of static charge. But what does that mean? Well, electricity has two major forms. Firstly, that of the flowing electrons, the electricity that is powering this video that you're watching right now, the screen that you're watching it on. And secondly, the one that we all have a bit of fun with in class, and that is static electricity. So, quickly, a quick question for you. What are the three types of charge that we learnt about in the last video that link to our subatomic particles? I'll give you a clue. Electron, proton, neutron. That's right. Positive, negative, and of course, neutral. So, to understand this concept, I'm going to use the tried and true, you've all seen it, you've all done it, the balloon. So, you may have seen this done at birthday parties, you may have done it yourself, you may have done it in class. When you rub a balloon against something, it does something very strange to your hair or allows you to stick it to curtains. But what is causing that? Well, think about the process of rubbing it against something. You're causing something to happen. Let me give you a clue. If you stand there right now watching this video and start rubbing your hands together, you will eventually feel a build-up of heat. What's that being caused by? That's right, friction. So friction's being built up. Friction is creating heat. What is heat a form of? That's right, energy. Energy is being transferred from one object to another. Just like energy can be transferred from one object to another, this can allow charge to be transferred from one object to another. Now, last video we learnt about that electricity is the flow of electrons. What if we started building up a charge on here as we were rubbing it against our hair or against a curtain? And lots of negative charges started to be built up. What if we then put it near something that had more positive charges, like Mr. Lloyd's head and his crazy hair? What would happen? You're right, the two charges would attract each other. Positive charges are drawn to negative charges and negative charges to positive. It's what keeps electrons around an atom. The positive charges of the protons in the nucleus draw in the electrons. That's why the outer shell can bounce off, because they're furthest away from the middle and the nucleus of an atom. So different charges attract each other. Some of you may have seen an experiment where, almost like a Jedi using the Force, a PVC pipe rolls a can away or towards it. This principle is the same. If the charges are the same, the opposite happens. The charges repel each other. So, static electricity is the build-up of charge on an object. That charge is not flowing, it is staying there, it is static. Different types of charges can attract each other, and if those charges are the same, they will repel each other. Finally, you can discharge a static electricity build-up, and you've often, or may have done this to each other, when you're wearing things like nylon, or you've been jumping on a trampoline. As you're jumping on the trampoline, you have been building up a charge through your body. That charge has nowhere to go until you touch something conductive. Often this can be the car door, or, if you're particularly malicious, someone else. Next time you're jumping on a trampoline, run and find your favourite friend and give him a little zap. See what happens. So, electricity at the atomic level. You now know it is the flow of electrons, but it can also be the build-up of static charge. I hope you've taken a lot out of this video and the last one. I'll catch you in class. Study hard.